All right, this is section 5.3 in pre-calculus, and in this section we are going to be solving equations that are in trigonometric form. You do have some techniques that you'd want to follow. First and foremost, you've got to make sure that you take anything that you've ever learned about solving an equation and you still apply the same rules. Okay? You can solve by using just plain old inverse operations. You can solve by setting your equation equal to 0 and trying to factor. You can also solve by substituting identities and at any time. All right, when we solve our first set of equations, the first 5 here, you've got examples A through E. We are going to be solving them on the interval from 0 to 2 pi. What that means is that my answer is going to be a radian measure anywhere within that first revolution. But that's it. Okay, so anywhere between 0 and 2 pi, we're going to find all solutions that would work for the specific equation. All right, here we go. This first example here can be factored. It's in a quadratic form, so I'm going to factor this to 2 cosine x. Cosine x. My signs are going to be different. One's going to be plus, one's going to be minus. And I need a positive in the middle, so plus here, plus 1 and minus 1. So there it completely factors. Once you factor it, the next thing that you're going to do is set each one of those equal to the 0. So 2 cosine x minus 1 equals 0. And that would be 2 cosine x equals 1. And cosine x equals 1/2. Okay. So in order for us to find the angle at which cosine is equal to 1/2, we think about the unit circle. When is the cosine a half? Well, the cosine is a half at, hold on one second, the cosine is a half at this angle right here, because the ordered pair is 1/2 and the root 3 over 2. Because cosine is the x value. So there's the triangle that we have a cosine of a half. Well, that angle is pi over 3. So we know that the solution is pi over 3. It would also happen in quadrant 4 at that same reference angle. So the same reference angle, 60 degrees or below. But if I go all the way around from 0, then that would be an answer of 5/3 pi. So at 5/3 pi, we have another value that would be equal to a half. All right, now let's go back here and look at my second one. What if cosine of x plus 1 was equal to 0? And then that would indicate that cosine would be equal to -1. So when is the x -1? We've got this ordered pair right here on my unit circle at pi, which would be -1, 0. That is the ordered pair. That's the point on which the cosine is equal to -1. So my final solution is pi over 3, 5/3 pi, and pi. Your goal when you solve these equations is you're going to be finding the angles at which these ratios occur. You got to keep in mind a couple things. So for example, right here with my cosine being positive, I was guaranteeing that we were either in quadrant 1 or 4. So we had to figure out when is it 1/2, those two angles. Okay. All right, let's look at the next example. 2 cosine squared x plus 3 sine x minus 3 equals 0. I've got cosine squared here, and I've got a sine x. We can't solve it unless you have them in the same terms. So we have to do some sort of substitution. I can substitute for cosine squared. That is equal to 1 minus sine squared. And then you can see that we've got all of our terms in the same trig function. We're going to distribute 2 minus 2 sine squared plus 3 sine x minus 3. Adding your like terms, we got -2 sine squared x plus 3 sine x. And then you've got -1. 2 minus 3 is -1. The last thing that I would do is I would multiply everything by a negative. Multiplying everything by a negative will just change your signs so that we have a leading coefficient of +2 minus 3 sine x plus 1. And the reason why I did that is so that we could factor. We typically factor expressions, and when we do that, we want our leading coefficient here, this number in the middle, to be positive. Right here, we want this to be positive. All right, so factoring this, I can get 2 sine x and sine x as my first two parts, and then we got plus 1 here, so 1 and 1. And my signs are both going to be negative in order to get a negative 3 in the middle. Set each one of these equal to 0, so we're looking at when is the sine of x, when will it equal a half, and when is the sine of x going to be equal to 1? That's the question. All right, let's look at our unit circle. Well, I know that sine of x will equal 1. Sine is the y value, so it equals 1 up here at 0, 1. Okay, so there's my angle. So we know that, I'll put my answers over here, pi over 2 is one of my solutions. Okay, I also know this, that sine of 1/2, when the y value is a half, we are at this 30-degree angle right here, or pi over 6. So it's pi over 6 here in quadrant 1, and it would also be then over here in quadrant 2, and that would be 5/6 pi. So that would conclude with the rest of my answers. Pi over 2, pi over 6, and 5/6 pi. Those are our three solutions to this equation. All right, looking at the third example, 1c, you can see here we've got secant and we've got tangent. We are not able to directly substitute one for another. However, there is a Pythagorean identity that says this: tangent squared x plus 1 is equal to secant squared. If I can somehow get tangent squared here, then I'd be able to substitute, and I'd be able to substitute tangent squared as secant squared x minus 1. So that's what my goal is. All right, I can get tangent squared if I square both sides. So take this to a power of 2, take the left side to a power of 2. Let's see what we have left. We've got secant squared x plus my middle term would be 2 secant of x plus 1 equals tangent squared x. Now tangent squared x then can be substituted for as my secant squared x minus 1. Let's see what we have left. Secant squared x minus 1. Now everything's written in terms of secants. Secant squared on both sides, you can cross them out. So we're left with 2 secant x plus 1 equals negative 1. I'm going to subtract the 1. 2 secant of x equals negative 2. Secant x equals negative 1. When is the secant negative 1? Well, that would also indicate when is cosine of x equal to 1 over negative 1, which is negative 1. So we could really identify when's the cosine negative 1. That's an x value. On the unit circle, x is at negative 1 here. Negative 1, 0. So that would tell us that that is also when cosine is negative 1, and that would indicate when secant was negative 1. So my answer is at pi. All right, in example D here, you also have a quadratic form. I'm going to go ahead and set everything equal to 0. By adding 1 to the left side, this can factor to tangent of x plus 1 and tangent of x plus 1, so there's two of them. When does tangent of x plus 1 equal 0? Well, that would be when tangent of x is equal to negative 1. So when is tangent negative 1? Let's look at our unit circle. Tangent is negative 1 in quadrant 2, so right here in the middle. That angle is 3/4 pi. The ordered pair there is negative root 2 over 2, positive root 2 over 2, and then tangent is also negative in quadrant 4, which should be the angle going all the way around at 7/4 pi. So that's my solutions, 3/4 pi and 7/4 pi. First of all, tangent is at -1, and tangent's negative in quadrant right here, quadrant 2 and quadrant 4. So then you have to decide where is it also equal to a -1, not just being negative. All these values are coming from your unit circle, the ordered pairs. All right, last example here for solving within the interval from 0 to 2 pi. On this problem here, I'm just going to inverse operation, do 3 tangent squared x equals 1. So tangent squared x would equal 1/3. Take the square root of both sides. You get plus and minus the root of 1/3. Let's simplify this down. Tangent of x would equal plus and minus 1 over the root 3, which rationalizes to plus minus the square root of 3 over the root 3. So in my unit circle here, where's tangent, the root 3 over 3? Well, that always occurs at all of the 30-degree reference angles. So here, it would occur there. And we're dealing plus and minus, so we're going to have all 4 answers. There's another solution. And then, of course, in quadrant 4. So we need to come up with all 4 of these radian measures. Well, since the root 3 over 3 is a tangent, it occurs at all the pi over 6's, we would have as our solution, it occurs at pi over 6, and here at 5/6 pi, and then here at 7/6 pi, and finally at 11 over 6 pi. So you can see there that we've got our positive tangent here in quadrant 1 and 3. Our negative tangents would occur in 2 and 4. So those are your solutions. We'll list them out here. Pi over 6, 5/6 pi, 7/6 pi, and 11 over 6 pi. All right, that is it, and we do have an assignment for our section here, but there will be a second video that kind of continues with our solving, and you'll get that assignment after the second video.